So the client had three major shutdowns in September 2010, July 2011, and January 2014. They were not able to get outlet temperature of 700 degrees. It was running 57 degree lower. The maximum tube metal temperature was exceeding the design value by almost 150 degrees, so they were almost reaching. They were at the maximum allowable tube metal temperature. The heater operation was severely limited, That's basically what was the situation in this crude heater. So this crude heater was a vertical cylindrical heater with 22-foot tube circle diameter and 62-foot height. Burners were installed at 11-foot 8 inches burner circle diameter. The burner to tube clearance should be 5-foot 6 inch, and they were only having 5 foot. And when we started looking at it, we said we would like to change your existing burners and put them at an angle. So we went in with new ultra low NOx burners and did the CFD modeling at a lower burner circle diameter to increase the clearance from the burner to tube, at least meet API 560. So we analyzed the problem and kind of recommended these simple solutions. The first was how to solve the flame impingement problem. So we said we will put new burners on tighter BCD using client firing, and we will use CFD to optimize the BCD as well as the inclination. So we ended up doing about 6 iterations of different angles and different BCDs to arrive at the best combination. We looked at the plenum and we redesigned the plenum, simplified it, and made sure that all the burners are getting equal amount of air using CFD. Then they were having limitations on natural draft, so we put fresh air dose, redesigned and relocated. And they were having combustion air limitations, so we recommended them to put a new FD fan, of a higher air capacity. So that's basically the modifications which we did for them. And our inclined firing is, we came up with 10-foot 3-inch burner circle diameter, and you can see we installed burners at 7-degree angle. We started with 5-foot 8-inch clearance, which is little more than API 560, and by the time we went to 25-foot flame, which was what the burner vendor had promised the flame length to be, we were at additional 3 feet. So 8-foot 9-inch clearance is what we created for them, So we were able to create, and even between the burners, we were able to create a big gap, So I want to show you now some slides of CFD model. We did extensive CFD modeling to come out with the optimum BCD and burner angle. The existing configuration, if you see, had a big flue gas recirculation taking place in the center. If you see over here, this was the flue gas recirculation pattern taking place, and it was pushing the flue gases down straight into the tube. That's what was happening. So that was basically causing the high tube metal temperatures or hotspots in the display. And if you look at our design in inclined firing, basically there was no such recirculation pattern forming, and it was forming much above, in the upper 1/3. So that's basically, you can see side to side. Now the important thing is flue gas temperatures, and here you see the hot flue gases going directly into the tubes. You can see over here, this is where the flue gas temperatures are impinging. A hot flue gas temperature almost like 2200 degrees. And if you see our design, it's much different. You have much cooler flue gases going into the tubes. The hot flue gases are concentrated in the center. And also, if you see in the existing design, the top half of this thing had very, very low temperatures. And if you see over here, we tried to make it a lot more uniform, So that was another major improvement we did by putting burners at an inclined fashion. The good thing with CFD is once your model is built and simulation completed, we can study the flue gas patterns, temperature, CO concentration at any cross section, horizontal or vertical. We compared flue gas temperature profiles every 5-foot elevation. At 5 foot, you can see compare side by side. And when you compare at 10 foot, you will see that the hot flue gases are in the tubes actually. If you see over here, this is basically, you see the high temperatures, And if you compare this, there's a total difference, stark difference between the two configurations. So we did this at 15 foot, also in 20 foot. And here you will see something very strange happening. You will see the cold flue gases is in the center and hot flue gases are outside actually. If you see over here, the hot flue gases are on the outside and cold flue gases in the center. Same thing happening over here, Whereas this is what we come up with, that the hot flue gases are still in the center, cold flue gases outside. Same thing at even 20-foot elevation. So very, very different heat transfer profile with inclined firing. We got much more uniform heat transfer profile. We did it even at 30 feet and 40 feet, and you can see the difference. I mean, I don't have to explain to you, they are all self-evident, We also looked at CO concentration, and typically in the industry, any concentration of more than 2000 ppm or red color is flame. And you can see at 5 foot, the situation is not that bad, but at 10 feet elevation, the situation is very, very bad. You can see over here. The flames are kind of spreading all around. And whereas in our case, the flames are centered in the furnace. And here at 15 foot, you could see the flames are almost in the tubes, and the core is the cooler. So the flames all around and core is whereas the burner should be there, And you can see the difference, In our case, it is much different actually. We have hot flue gases in the center, the flames are in the center, and cold flue gases, no CO outside. So the flames are kind of restricted, So we did extensive CFD modeling, convinced ourselves, convinced our client to ensure that once we put these burners, high tube metal temperatures will be history. You won't have any issues, So in CFD, typically anything more than 2000 ppm or 2500 degree flame temperature, flue gas temperature is considered as flame. And you can see the existing space where we have these flue gases, the flames impinging on the tubes, and that's where they were having this thing. So it was almost like a cloud into the tubes. And when we did it, you can see everything is in the center, Now flames did become a little longer, I would say about 4 or 5 feet, but everything was contained in the center actually. And we also did several models. We looked at the TMT models. What we do is we take the FRNC heater simulation output and put it in our CFD model, Fluent model, merge the two or marry the two. And then we see, and here you can see the flux radiant tube metal temperature profile and existing and revamped actually. And I can show you, we have almost like 60 degree, 65 degree temperature reduction. Now, in reality, in real life, we got more than 100 degrees reduction in tube metal temperatures. The heater has been operating successfully for last 5 years without a shutdown. No flame impingement has been observed. So this shows you the flux profile in the 3 sections: top 1/3, middle 1/3, and bottom 1/3. And you can see we were able to reduce the bottom flux from 20,000 to 15,000 and increase the middle 1/3 from 11,000 to 17,000. So we made it a lot more uniform as compared to what they had before. And the overall heat flux still remained the same. So there was no reduction in heat transfer in the radiant section. I just want to tell you once again. So in summary, there are several benefits of inclined firing: significant reduction in tube metal temperatures, low coking rates, higher tube life and run length. You don't have any flame impingement. You don't have any hot spots. In most of the cases, we are able to increase the capacity also, and uniform firing achieved across the tube. So uniform heat transfer is possible through inclined firing. This picture is from our first installation at Delek. You can see the ultra low NOx burners in an inclined fashion. This is just to give you a little history of our references. The first 2 heaters, we installed it in 2010. Then later on, we installed it at a very large crude heater at Citgo Corpus Christi, which was having tube failures. We installed this in 2012. We have installed it in HPCL Mumbai in 6 heaters, and they have been working very nicely. We installed it in Countrymark DHT charge heater, and when we did that, we increased the capacity of that heater by 60%. We did a new hot oil heater for Gladio with 6 burners at an angle. Valero is the one which we presented you the case study today. Then we did another project at Sasol. This was a brand new heater where we put 12 burners in an inclined firing. That heater has started. And all these projects have been working very, very successfully. And I just want to let you know that this is a very simple concept. We want to show, that's what we wanted to show it to you today. We are very confident if you use this technology, you will get rid of hotspots and flame impingement. You will be able to extend the life of tubes. You will have a very good performance. So if you have a heater which is facing issues, it could be any heater, it could be coker, cracking, crude. We would like to evaluate and let you know whether inclined firing is a viable option. Well, thank you very much for giving me a patient hearing. I am very sure that you must have learned a few things today. Please send your questions and I'll be more than happy to answer these questions for you. So I have a few questions over here. The first one is, can we go for inclined firing for both fuel oil and fuel gas burners? Yes, you can do that. I don't see any problem. Can we fire both fuel oil and fuel gas burner together in the same burner block? You can do it. Normally, it is not recommended actually, but typically you can do it. I mean, if you're currently doing fuel oil, fuel gas firing in your existing heaters or existing burners, you can continue to do that. We don't see any problem. HPCL burners had combination firing. I just want to let you know that HPCL burners were combination burners. What will be the percentage of free radiation duty of the total heat absorbed in the radiant section? Generally about 70-30. So 70% or 75% of the heat is absorbed by direct radiation and 30% by re-radiation. That's basically the typical number between the direct radiation and radiation. What is the effect on NOx emissions? Did you see any increase after installing inclined burners? Good question. No, there is no effect on increase on NOx. If NOx would increase, no refiner in US would let me install these burners. So when we installed it in Citgo, we installed it in Valero, any project, we made sure that the NOx emissions were within the limit. So no NOx increase, we will guarantee that. Wouldn't inclined firing burners create problems with air and draft control? No, it won't create any problems. You will still be able to control the combustion air and draft like what you were doing before. So we don't think that that should be a problem. What was the increase in cycle length between the heat tube decoking for coking furnaces? I mean, I would say it will go almost like from 6 months to 2 years. That's typically what I would tell you. Is inclined firing technology applicable to combustion combination fired fuel gas fuel oil burners? Yes. Do you supply burners? Yes, we supply burners. I mean, that's basically, I think we can help you by specifying the burners correctly. Have you installed inclined burners in a down-fired reformer? We did a study for one installation, and typically in the end walls where you have the 50 or 60% burners, those are the rows where we can install the burners in an incline. Can the inclined burners be pulled out for cleaning while in operation? Yes. It's almost, these burners are almost in the same manner as vertical burners. So there is no difference. You won't even see the difference of 5 to 7 degree angle, So you can pull them out for cleaning, you can take them out for maintenance. We don't see any issue there. What are the maintenance requirements for inclined burners? Still the same. It's not any different. What about the impact on bridge wall temperature? No effect on bridge wall temperature. I showed you the flux remained the same. It did not change. Good question, actually. So the flux remained the same, and we have done this in several heaters. And basically, as I said, the flames do not come into the picture when we are doing the radiation heat transfer. What could be issues for inclined fired coker heaters if inclined towards the refractory and heats it? So we make sure that your refractory is able to withstand these flames, and also these ultra low NOx flames are much cooler flames as compared to the standard burners. So we don't see any issue. It can be done without any major modifications. How about the effect of emissions for the same type of burners? No effect on the NOx. Otherwise, we won't be in business or installing this in so many heaters. We make sure that your NOx emissions are never, So would you need to install redesigned burners to address different flue gas patterns? No, actually, I can reuse your existing burners also. I mean, in Citgo, that big crude heater, they said we don't want to go for new burners because of the permit issues. Why don't you use the existing burners? And I use the existing burners. So I can use your existing burners and put them at an angle without any issues. Some cases where we see that if the burners are not sized correctly or designed correctly, or we see a specific reason for changing, so we change it actually. But we can use your existing burners. Do we have to change the refractory to BICS if the flames of burners are impinging? I think it will have to be very, very specific. We will have to look at the refractory. My guess is most of the refractory we put in these heaters are designed for 2300, 2400 degrees F. So we don't see any problem in the refractory. However, it will have to be checked. Yeah. Can we go for alternate or at random fuel oil fuel gas firing? I don't see any problem there. I mean, if you want to use, if you talk to burner vendors, they will recommend that why don't you fire oil in one burner and gas in another burner. They generally don't recommend you to fire both fuels, so you are good actually. I mean, to continue doing whatever you're doing. What are the changes to the floor? Very little actually. We normally take a portion of the floor, which is to be replaced in most of the time. So we take that portion of the floor, prefabricate a new floor, inclined floor, and put these burners, prefabricated. In one case, we even did not change the floor. We just added one very small portion, So the floor changes are very, very minimal actually. What will be the time required for modifications? We have 14 burner blocks per heater zone with 55 giga. Most of the time, I think 2 to 3 weeks is typically the turnaround time for most of the jobs. The good news today is that we can prefabricate everything in the shop, bring it in modules, and then just change the floor plate or change the burners, adapter kit. So it can be done very, very fast actually. The ceramic fiber refractory cannot withstand flame impingement. Yes, you're right, Halim. I mean, it can be done. But you have to put something, which can withstand or do some other modification. We will post the webinar on our website, and also and you will get a link for the recording, so you will have the presentation. Well, thank you all for giving me this opportunity to present high tube metal temperatures issues and how it can be solved by inclined firing. If you have any heater, we will be more than happy to look it over and get back to you with our recommendations. Thank you again. Have a nice day. Bye.